This is the Chapter 10 practice test. The first one, put a circle around all the growth functions, put a box around all the decay functions. So circle, a different color as well. Box goes around the decay. So the growth function base number. So this one, that base number is bigger than 1. If it is bigger than 1, it's a growth. So that's a growth. This next one, base number, that 3 is not what you're looking at. That's actually the y-intercept. We'll talk about that in a second. But this base number is smaller than 1. If it is k. Next one, again, they try to trick you. Other one did. 0.8 is not what you're looking at. Again, that would be the y-intercept for this one. The 5 is what you're looking for, and that is bigger than 1. Also tried to trick you with this one. This 5 is a fraction, so a lot of people think fractions are always smaller than 1. But if that number on top, that numerator is bigger than the denominator, then it actually is bigger than 1. You put it in your calculator and check if you need to. And the last one, 1.2 is what you're looking at. That is bigger than 1. Quiz. A lot of these, there are a lot of questions on this test, and I'm trying to figure out how many to keep on and how many to take off, like kind of as we speak. That's my next thing to do. But a lot of these don't take very long. So like the one we just did, exponent, growth, or decay, it should take very long to see. What's the y-intercept? Y-intercept is this too. That's it. If you know what you're looking for, a lot of these questions don't take very long. This one, what's the transformation? So this transformation up here means we go 9 units to the right. So right 9, and then the -7 means down 7. Again, if you study and if you have that memorized, this should not take very long. The next one does take a little bit longer. Evaluate algorithm. Equal to x, and then put it in exponential form. 27 raised to the x is equal to 243. I will tell you with this, or thing you can kind of do as a shortcut that may or may not work. Set up like this. You only have 4 different options. 27 raised to which one of those numbers is 243. So if it is multiple choice, you can do that. I think there's maybe one like that on the quiz. But the actual way to do this, there's 2 ways to do this. And I think I showed you on the answer key, I showed you both ways. Make them both have the same base. So I can't make 243 have a base of 27. 27 squared, I think, is already too big. Yeah, 27 squared is already way bigger than 243. So we have to change both of the bases. So I'm going to change 27. The only real option for that is 3 to the third. 243 and 3, so 243 is 3 to the fifth. 3 times x is 3x, equal to 3 to the fifth. And then we can divide these. Since the bases are equal, we set them equal to each other. Set the exponents equal. And then divide both sides by 3. I get equal to 5 over 3. As the decimal is 1.67 round. 5 over 3, that's fine too. So the other way to do this one, not to like waste you guys' time, just put it over here. So if you have 27 raised to the x, raised to the x is equal to 3. The other way you learn how to do this is you, since your variable, there's only one variable in here, it's only on one side, it's on the left. You can take the natural log of both sides. The log of both is supposed to take the natural log. So that x goes in front, so that's x times the natural log of 27 is equal to the natural log of 243. And from here, just divide both sides by the natural log of 27. So your x is equal to, if you put that in your calculator, natural log of 243 divided by the natural log of 27, you get the answer. No matter which way you do it, it depends on you. I can definitely see where some of yours this way. Some of you guys think that way is going to be a lot easier. I think when you actually get room of this, I think that second way is the natural log is a lot easier. It kind of just depends on what is easiest. So the next one, evaluate log of 10,000. Now, again, I like to give you guys, if you're trying to smile, if you're actually trying, I like to help you as much as I can, or at least help you more than people that don't try it all. So one quick thing with this one, log of 10,000. If this is a multiple choice question, just put that in your calculator. Log of 10,000. Remember, log base 10. That's what button is in your calculator. So if it's multiple choice, I don't care if you show your work. So definitely in your calculator. But technically, this is base 10, and then we get to do this we did before. So 10 raised to the x is equal to 10,000. Now again, you can use the natural log method, or you could use the method, but this, since it's 10, I always just know that 10 raised to whatever that exponent is how many zeros you have. So I have 1, 2, 3, 4 zeros. So that x has to be 4. Now again, do this one since we didn't have bases. So 10,000 would be 10 to the 4th. 10 to the 4th. So that's another way to do it. Or again, obviously, then move the x in front. You can do it that way as well. For any exponential, it's all real numbers. So hopefully it doesn't take long. And then the range for this one. Now this one opens downward like this. So your range is always your y values. You can see the shape of this. It gets really close. -2 with that -2, but that means that's that asymptote. So it never crosses -2. So my y is paired with -2, but it's below the less than. Some of you guys had a little bit of problems setting this up in the. I would put an exponent for first, 4 raised to the x over 256. Some of the calculators, you can put that in your calculator and it just does it for you. Again, if this is multiple choice, there's no way to know that because I don't check your work for that. But if it's short answer, if you just have x is equal to -5 or whatever the answer is, or -4, I think it is, that's great, but I'm not going to give you credit unless you show me some sort of work. You do not have to do it the same way I tell you to do it, but you do have to show me your work. So your exponent sheet, we have 256s in the denominator. So I always ask myself, 4 raised to what number? And I'm going to make it y, because I don't want you guys to think that they're both they're the same, the x and the y. What would I take to get 256? Your exponent sheet for here, so that's 4 to the 4th, is 4 to the 4th. To make it 1 over 256, you need to make that 4 into a -4. So for this one, my x is -4. Solve this one. Again, there's a couple different ways to do it. You could also make the bases the same. So 25, I can make it the 5 to the 3rd. Really, and if you're wondering how I can come up with that, if you look at your exponent sheet, if you just look for 125, it shouldn't be hard because the numbers get bigger. 125 only shows up once, so it's got to be 5 to the 3rd. That's the only option for 125 here. Not here, not here, and again, there's not any other options for that if you look. So I make 6 and the 5 raised to something, so 5, yeah, 625 right here, that's 5 to the 4th. Multiply this out, so 5 raised to 3x is equal to 5 to the 4th, and since the bases are the same, now we can set those together. Divide those by 3, x is equal to 4 over 3. I mean, you could leave it as that fraction, that's fine, or 1.33. I don't care which one you do. Then again, the other way to do this, since your exponent, there's only one exponent, or sorry, I shouldn't say, there's only one variable as your exponent, it's all on the same side. You could also take 125 raised to the x is equal to 625. Take on both sides. That leaves that x in front. So x times the natural log of 125 is equal to the natural log of 625. And then again, just like the one we did, one of those other ones before, divide both sides by natural log of 125. And again, remember, if you don't want to use the natural log, you could use that log button in your calculator. That's fine. It does the same thing. For our purposes, it's interchangeable, except for that one problem where we're doing compound interest when we're compounding continuously. That's the only time you need to use natural log. And so for me, I just always use natural log because that way I don't have to worry about it. I don't have to think about it. Those cancel. I have x is equal to, if you put that in your calculator, again, it gives you the identical answer, 1.33. Next one, number 9, we're writing this as a single logarithm. So the first thing we need to do is 3, put it up, the 6, put it up. And when you do that, you're putting it up as an exponent. There's a lot of people on the quiz that had 15 here, and so they're taking 3 times 5. No, it is 3 raised to the 5th power. 5 raised to the 3rd power. Close. 5 raised to the 3rd plus log base 3 of 2 raised to the 6th. So to make this into a single logarithm, now we have to simplify that out. Take 5 to the 3rd is 125. Use a calculator or use your exponent sheet. 2 to the 6th, again, you could use your exponent sheet. I just use a calculator. It's what I'm more comfortable with. That's 64. So when you add these together, remember logarithm since base, and we are adding, that means we can multiply our numbers. So log base 3 of 125 times 64. That ends up being log base 3 of 125 times 64 is 8,000. Now, some people on the quiz, they were taking that and then they were actually solving it. 3 raised to 1 number is 8,000. I guess if you want to do that, you can, but you don't have to on this one. It's not telling you to evaluate. It's just telling you to write it as a single simplified logarithm. Is different because now remember there's 2 types of problems like this. Number 11, one of them has logs on both sides. One of them just has logs on one side of your equal sign. So those are done a little bit different. We'll find this out. So that 2 goes next. Technically, if you want to put base 10, you can. As long as you know the bases, that's really what matters in this problem. You have the log simplified, where there's only 1 on both sides. You don't have to be multiplying in front or anything, so it's as simplified as I can get. Since they're the same base, now we can forget about those and just set the x squared equal to 49. Remember, if you put plus or minus 7, you can, that's fine, but technically it's not -7, it's just a positive. Again, they're both log base 10, but they are on the same side, or I should say, there's no logs on the right-hand side. So again, the first thing you're going to do is combine these. I think I just noticed a mistake I did. Yeah, this should be a plus. I need to change that. It's funny, your key and I just went too quickly. So it should be plus, so we multiply 5 and x plus 2. So log base 10 of times x plus 2, 3, which is log base 10 of 5x plus 10 is equal to 3. So from here then, this is what is different than the last one. Now you're going to make it into exponent form. So 10, your base, raised to the 3rd is equal to that 5x plus 10. And then you're going to solve this one. So 10 to the 3rd is 1,000. Use your calculator if you need to. Subtract 10 from both sides. This is just a normal multi-step equation we've done before. And divide both sides by 5. You get x to be 198. Two decimal places. Now, they're giving you a hint when they tell you to round. But if you tried to do this one where you tried to make them have the same base, there is no 85. I mean, look over your exponent sheet. 3's right here. There's no 85 on here. So I can't change 85 to have a base of 3. And I can't change 3 to make it any smaller. There's no numbers that, with an exponent, with a whole number exponent, give you 3. So the only chance you have for this one is to take the natural log of both sides. Puts the exponent in front. So we have x times 3 is equal to natural log of 85. And then, per usual, divide both sides by natural log of 3. You get x is equal to natural log of 85 divided by the natural log of 3 is 4.04387, which rounds to 4.04. Pretty quick ones. Put it in exponential form, so it's just 8 raised to the x is equal to 12. Put it in log form, it is log base 6 is equal to x. We don't have like a great way to memorize that. You're just going to have to sit down and memorize it on your formula sheet. You see this. This is what your formula sheet will be. All of your exponent sheets help you choose equations. A graph of the following. Now, one of the big mistakes a lot of people have, this is the y-intercept. That is whether you say growth or decay. This one will be a growth. So whatever it looks like, it's going to look something like this, just moved around a little bit. So if there's not a number in front, that is your y-intercept, and my is at 0. Earlier when I said that's your y-intercept to start with, we're going to change that now. We're going to move it to the right 3 and down 2. So to the right, 1, 2, 3, down 1, 2. Your x goes to the right, 1, 2, 3, down 1, 2. So again, on the left-hand side, I start close to that dotted line, and then I don't cross it until we get there. But again, I really just am checking the general shape. That's before. This order pair to make sure it's right. I check asymptote to make sure it's in the correct spot and that you don't cross it. And I check to see if it's a growth or decay and what leaf shape it is. Those are the only 3 things I look at for those. We do have a y-intercept for this one. It doesn't change from that. The asymptote always starts at 0. And that's just our start point. It means we move it to 1. We also, and it doesn't change anything because it's horizontal. And last but not least, this one is smaller than 1, so this is a decay. So when we come down, again, just make sure you come to that point, and you don't ever cross your asymptote. Again, so 5 raised to the x is equal to 6. So again, you make 2. It is here, so you can make it at a base of 5, 5 to the 4th. So x is equal to 4. Done is literally just look at your exponent sheet. If you don't show me on this one, I'm show me your work, but once you have this listed out, 5 raised to but then you just say x is equal to 4. Yes, if you just look at your exponent sheet. This one's a little, oh, sorry, before I get it. Again, we have the variable is only in on one side, so again, you could take your 5 raised to the x, 625, and you can take the natural on both sides. 5 is equal to natural log of 625. And you would put that in your calculator, it will give you the exact same answer. 18, same thing like this a little bit earlier, is equal to 8. There is no, it's going to be a decimal, so I'm going to change it to 2 squared. 8, I'll change it to the 3rd. So it's 2 raised to the 2x is equal to 2 raised to the 3. So 2x is equal to 3. Divide both sides by 2. X is equal to 1.5. We have 4 raised to the x equals 8. Whoops. X times the natural log of 4 is equal to the natural log of 8. Divide both sides by the natural log of 4. You get x is equal to, same thing, 1.5. So same as before, just as a single so you're multiplying those, so it's going to be log base 3, 21, sorry, 27 times 81. 27 times 81 is, so this is log base 3, 2187. Now again, technically, I think you'd solve this more, but we don't need you to. We're asking you to write it. You do not need to solve. We're not worried about that for this one. This one, take that 5 and put it up as your exponent. So we have log base 6 of x to the 5th. Not a lot of simplifying you can do after that. We were talking about earlier, the other ones we just said, but this one we don't want to evaluate at the end. So if it is subtraction, it's division. So 1, 5, 3, 6 divided by 3 is 512. So base 8, 12. And put this into exponent form. X is equal to 512. And as I've said with all these other ones, or at least a lot of these other ones, we have a variable, or there's only one variable, or it's only on one side, however you want to look at it. One way to do this, since it's like that, is take the natural log. So I guess I'm kind of doing a different order. So that x comes first. Divide by natural log of 8. Natural log of 512. Natural log of 8 is 3. Or we could do like all the other ones we did, and I meant to do that way first anyways. Raised to number is 512. 8, 512 is right here. 3. Either way is fine. Don't mind that. So next thing we're going to get into is the story problems or the compound interest problems. So what to do is I like to double check so I actually know what variables I'm using or what equation I'm using. All you need to do is look, it says blah, 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 compounded continuously. So that means we're using the continuous equation, that's this one. A is equal to PE raised to the RT. So I need to find amount. That's what we're going to be looking for in this one. Your principal put in, so that means that's 0.07. Make sure you put that as a decimal, and we're leaving it in there for 15 years. So we don't know what that A is. I'm trying to find. We have 4,000. E raised to the 0.07 times T. So use your calculator. Honestly, I would type that in exactly how you see it since it's not super long or not complicated. Make sure some of you guys will need parentheses around these. Totally depends on how you enter it in. Just again, when you're doing these, if you're getting the wrong answer every time, even though you think you're typing it incorrectly, let me know or double check those parentheses. So this one ends up being 11430.60. So how much that account has in it? 15 years. The next blah, 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 continuously. So again, we use the same equation. N is equal to PE raised to the RT. T, remember, E is just a number. It's a button in your calculator. So my P is, oh, sorry. Goal is that, so that's my final amount. Excuse me. Your P is your is 5%, 4.5. We want to know what the T is for that one. So again, plug your numbers in. We have 100,000 is equal to times E 0.05. Sorry, I think I fell asleep there. And start simplifying this. So remember, the ones that are like this, you literally do them all the same. The first step is to get rid of that 8,000. 100,000 divided by 8,000 is 12.5. 0.05, that was close, raises the T. So remember, this is the one where the natural log is the one that, I mean, but it's going to be way worse. The reason natural logs is because of this. When you take the natural log of both sides, this side doesn't change a lot. But the other side, that cancels, and all we're left with is this exponent, 0.05t. Now, it's not an exponent, so the last thing you need to do is divide by 0.05. Natural log of 12.5 divided by 0.05. Excuse me. It'll take roughly 5.5 years. If you round that up to 6, I don't care. Either way is fine. I don't think I did something right. What did I type in wrong? I bet. So here's what I did wrong. And this is, I'm only saying it because it's a minor thing. I put parentheses around the fraction, and I should have just put it around this first part. So it's the natural log of 12.5 divided by natural log of 0.05. So basically, it was just a computer or a calculator error. Still struggling. So this should be 50.5, much better, or 51 years. Either one is fine. All right, that makes more sense. Next one. Brent has $4,848 in the savings account. Blah blah blah. Content compounded monthly. So now, if it's monthly, now we're doing something different. Now we're using this equation. A is equal to P1 plus R raised to the n times T. And again, our variables, we have A, P, starting amount is 848. My rate is 0.05. That's great. It says compounded monthly, so monthly 12 times a year. And how many years you're going to put it in, that they don't tell us. Plus the final amount of 10,000. So this is the one than the last one. But before we even start, I'm looking for the T, and so I know I'm going to need natural log in here somewhere. So I know if the T is what you're looking for, it's a question mark 97, you're going to need the ln somewhere. So 10,000 is equal to 848 times 1 plus your 0.05 over n raised to the n times t. So we're going to have to start chipping away at this. Remember, this is where we kind of did 2 steps in one. Let me make sure I'm wrapping this up. How about 10 minutes? Where I'm going to divide both sides by 4848. That cancels. 10,000 divided by 4848 is 2.06. I'm going to do 27. Again, I like to go to 4 decimal places unless it's my answer. If it's my answer, I'll go to 2. But in the middle of my work, I like to do that. Then the other thing we can put in our calculator, 1 plus 0.05 divided by 12 is 1.0042. Again, I would at least go to about 4 decimals and then raised to the 12t. So the 2 steps I divided, but then I also combined some stuff over here to make it look a little bit nicer. Now again, this is where you run into a little bit of trouble. Like we said earlier, since we're looking for t, this is where you need to take the natural log. We don't have anything else we can really do to simplify that out. So the natural log of both sides, that 12t goes in front. The natural log of 1.0042. Oh, forgot about the 12t. I was going to say, I was like, that doesn't look right. Okay, sorry, the 12t moves in front, 12 times t times the natural log of 1.0042. Now, this is the other thing that I'm going to tell you to put steps in one easier. Please realize we're multiplying the 12 by t and the natural log by t. So really, we need to divide by both of them. So we're just going to divide by both of them at the same time. Whoops. This is just how my day's going. That's not adding. This is multiplying. Again, we're multiplying it by t, so we're dividing those multiplied. 12 times natural log of 1.0042. So type that in. We have natural log of 2.0627 divided by, and I always do in parentheses. I don't know if you have to. 12 times natural log of 1.0042 ends up giving you 3.7. So I'm double checking because that was also different than what I got earlier. So everything looks, let me put my calculator in. Natural log of 2. See, I forgot a parenthesis. I forgot one parenthesis, and that made my answer 3 instead of 15. So natural log of 2.0627 divided by 12 times the natural log of 1.0042. There we go. So I end up getting my t, because these cancel, t's all by itself. 14.04. Technically, that would round up to 15, but whether you put 15 or 14 or 14.04, I don't care, as long as it's somewhere in that range. But again, that tells you where you've got to be paying attention to how you put these in your calculator, and that's why you have to get some practice before the test, because I'm going to be way less likely to help you on the test, because again, nothing shows me that you didn't prepare for the test more than you don't know how to put some things in your calculator. So make sure you are getting practice. Okay, let's get through these last ones. Decimals if necessary. Now again, first off, when you look at this one, you could use the natural log for this one because the only variable we have is all on the same side. You could not use the natural log for this one. It's not going to work very well because you have the variable on both sides. So you can keep that in mind. For this first one, because it's already set up and the bases are the same, so all we need to do is set those extra equals to each other. Yes, you could use natural log, that's fine. I'll talk to you guys through that here in a second, but I will not use it. It's like normal. 17 plus 5 is 22. 2 divided by 2 is 11. I would take 6 raised to the 5th is 776. 7776 equal to 17. And then I would take the natural log of both sides. This in front, it would be kind of a lot. Be doable for sure. Since it's already set up, especially since it obviously has the same bases, that's the way I would do it. This one, you cannot use the natural log. And I'm sure you can, but it's definitely going to be difficult. I would have to think about it, but since we have variables on both sides. So for this one, I'm going to change the base of 1024. If you look at your exponent sheet, that is on here. That is 4. Change 1024 into 4 to the 5th. So that is 4 raised to the x minus 3 is equal to 4 raised to the, make sure you distribute that. A lot of people have 5x plus 1. Even though I warned them of that, you need to make sure you multiply both of those. Bases are the same. We have x minus 3 is equal to 5x plus 5. Subtract x, we have negative 3 is equal to 4x plus 5. Subtract 5, that's negative 8 is equal to 4x. Divide both sides by 4, you get negative 2 is equal to x. Sorry, that's a different answer than I got on my I did not multiply this one by 5 like I've just been preaching to you. So again, it's very common where you're just going too quickly. So just try to make sure you're staying on top of that. I can't believe I made that mistake. Next one, since there's only a variable on one side and the bases aren't the same, you could use the natural log. And again, on number 25, you could use natural log. I just think it would take way longer. One way to do this, and if you just look, 3 raised to what number is 729? 3 to the 6. X is equal to 6. I prefer you to show your work a little bit and put 3 raised to the 6. If you just x is equal to 6, if I can't be wrong, let me know and talk me through how you did it, and that will be back for that. The other way to do this, the natural log of sides. That puts that x in front, so x is the natural log of 3 is equal to the natural log of 729. Both sides by the natural log of 3. Getting 6 that way. This next one, there is no, if you look at 5, here, so you cannot make them have the same base. So this one is the one that you are required. You have to take the natural log of both sides. Put that x in front. X times the natural log of 5 is equal to the natural log of 500. Divide both sides by the natural log of 5. Make sure you use parentheses correctly, like I've been messing up. That should give you x is equal to 3.86. Guess we only have 2 left, so we should be okay. Logs on both sides compared to having logs on one side. Let's do a little bit differently. So this one is our exponent. It's equal to 343. Since they're all the same, I can set those equal. 3 is equal to 43. And you either use your exponent sheet or take the third root, doesn't make any difference. Either way you do it, you end up getting 7 for that one. The next one, since this is adding, we are multiplying to make it into a single logarithm. So x times 5 is 5x. Then from here again, now since we only have the log on the left-hand side, we can't cancel anything. We have to put it in exponent form. So 15 raised to the second power is equal to 5x. So 15 squared is 225 is equal to 5x. Then divide both sides by 5. 225 divided by 5 is 45. So if you have any questions, let me know. I apologize, I made a couple mistakes. Hopefully I caught myself and corrected those, but I probably have a mistake in here somewhere. Obviously, if you have any questions, let me know. Best of luck studying and good luck on your test.